You ever look at the ocean and wonder what's really going on beneath that calm surface? Well, today, we're pulling back the curtain on one of nature's most powerful events, the tsunami. We're going to get into where they come from, how they can travel totally unseen, and why calling one just a giant wave doesn't even begin to cover it. Seriously, just stop and picture that for a second. Not a gentle swell, but a literal wall of water, moving with more force than you can possibly imagine. It's an intense image, right? And it really gets to the heart of the sheer scale we're dealing with. Right, so that's the big question. How does that happen? It feels like it just appears, but the truth is its origins are deep, deep within the Earth itself. And to really get it, we kind of have to forget everything we think we know about normal ocean waves. So let's just tackle that big misconception head on. Is a tsunami just a really, really big wave? The answer is a hard no, and that's what we're going to dig into first. Okay, so think about the waves you see at the beach. Those are basically surface level, right? They're created by wind blowing across the top of the water. A tsunami, though, it's a completely different animal. Its power doesn't come from the air above. It comes from a massive jolt of energy from the solid earth below. And that's the key word right there, displacement. It's not about pushing the water, it's about lifting it. Imagine dropping a pebble into a pond. Now scale that up to the size of a city being dropped into the ocean. Something huge has to move an unbelievable amount of water all at once. And this right here shows you everything. Look at that wind wave on the left. All the action is on the surface. But the tsunami? Whoa. Its energy goes through the entire water column, from the ocean floor all the way to the surface. That's the hidden power we're talking about, and it's what lets it cross an entire ocean without losing steam. So if it's not the wind, what on earth has enough power to move an entire ocean like that? Well, let's get into the birth of these giants. This is ground zero, and it's not a slow buildup. It's a sudden, violent transfer of geological energy. It's almost like the planet itself just punches the ocean from underneath. So the number one cause, an underwater earthquake. You've got these massive tectonic plates, and one suddenly shoves itself under another. This violently thrusts the seafloor up, sometimes by several meters. This acts like a giant paddle, instantly shoving the entire column of water above it. The energy released in the 2004 Indian Ocean tsunami, for example, was equal to more than 20,000 atomic bombs. All that energy now has to go somewhere, so it radiates out in all directions. The tsunami is born. And while earthquakes are the main trigger, they're not the only game in town. A huge underwater landslide, a volcano erupting from the seabed, or, and this is wild, even a big meteor hitting the ocean can displace enough water to kick off one of these devastating waves. So once this wave is created, it starts its journey. And this is the really sneaky part. It becomes this hidden threat, traveling completely unnoticed across thousands of kilometers of open ocean. Yeah, just look at that number. 800 kilometers per hour. We're talking about the speed of a commercial jetliner. It's just mind-boggling to think about that much water moving that fast. So what this means is that a tsunami set off near Japan could hit the coast of California in just a few hours. It's not a local problem, it's a global one, silently racing across entire oceans. And this is the craziest part. All that speed, all that energy is moving deep under the surface. Out in the middle of the ocean, the tsunami might just be a gentle meter-high swell. A ship could sail right over it and have absolutely no idea that a catastrophe is silently screaming past underneath its hull. But that silent, stealthy journey has to end. When the tsunami finally reaches the coast, all of that hidden energy gets unleashed in the most terrifying way you can imagine. This table really shows the incredible transformation. As the wave moves into shallower water near the coast, the bottom of the wave starts to drag along the seafloor. It's like hitting the brakes. But all that energy and momentum has to go somewhere, right? The wave's speed drops like a rock. But in this terrifying exchange, its height just explodes. Exactly. All that incredible energy that was spread out through the deep ocean gets squeezed and compressed into a much smaller space. It literally has nowhere else to go but up, piling the water on top of itself and creating that destructive wall we talked about. And this is probably one of the most critical, life-saving facts to know. A tsunami isn't just one wave. It's a series of them, a wave train, that can hit minutes or even hours apart. The first sign might just be the water suddenly pulling way back from the shore, but that's the ultimate warning sign. People might think it's over, but the second or third wave can be the real monster.
Okay, I know this all sounds incredibly scary, maybe even unstoppable, but here's the good news. By understanding how they work, science gives us a real fighting chance to prepare and to save lives.
We've built a whole global network to keep an eye out for these things. It starts with seismic detectors that feel the earthquake, giving us the very first hint. Then, special buoys out in the deep ocean can actually measure the change in water pressure as a tsunami passes over them, confirming the threat and beaming a real-time warning to warning centers around the world. And that knowledge is power. Early warnings are everything, but so is being ready on the ground. This science helps engineers design smarter buildings that can withstand the force, and it helps city planners map out the safest evacuation routes to get people to higher ground fast. So, really, when we look at a tsunami, we're not just looking at a wave. We are getting a glimpse of the raw, incredible power of our planet. It's a humbling reminder of the massive forces that are always at work, shaping our world from the bottom of the sea to the land we live on. Which really leaves us with this big question. We've learned so much, but our planet is always changing, always moving. The real challenge is to never get complacent, to keep learning, and to make sure our understanding can keep up with the Earth's immense and often unpredictable power.